Hello everyone, I'm Mirindra Rakotoarisoa and I'm very pleased to be with you today to talk to you about our preliminary results on the research that we did with the project Forest for Climate and People. I am from the University of Antananarivo and it is a project also with the Bangor University. So yeah. Remote sensing can be an important tool for understanding the development of forest cover and landscape characteristics. It might not be well suited for detecting human settlements, especially in forest nest area in tropical forest frontier regions, for instance, and as a result, it may risk underestimating forest communities' population, which can have important application for their roles in forest conservations. This our study aimed at analyzing how well do remote sensing datasets can locate forest-proximate people by comparing high-resolution human settlements dataset with ground data, and to achieve that in order to achieve a fair and equitable conservation outcome for people and nature. So, our methods. Our study area is on the northeastern part of Madagascar, and we mainly used three main datasets for our comparison. And our approach is by doing a grid by grid comparison between those three datasets. And the first one is a world settlement footprint in 2015, which was from Marcosini and Strano. And the second dataset is the WorldPop dataset, which shows the density for each countries. And the last one is the ground dataset from the northeastern part of Madagascar, which was from Schubler. We did an analysis of the detectability of the global dataset, the world settlement footprint dataset, through a logistic regression. As a response variable, we have yes or no. That is to say that if a grid does contain a village or not. And as explanatory variables, we use the distance to forest, the distance to major pathways, the altitude and the slopes, and finally, the distance to river. Also, we did compare this detectability using a chi-square test, and finally, we did correlation comparison between the WorldPop dataset and the ground data from Dominique Schubler. First results. By comparing the ground data and the world settlement footprint, we had that only 15.3% of the actual villages were detected by the global dataset. And by running this the chi-square test, we have the result that smaller villages were less likely to be detected by the global dataset. On the other hand, all larger villages were detected, as we can see on this little chart, little figures. As we can see that once the villages have 2020 and more household per kilometer square, the global dataset were able to detect them all. And by analyzing this, the factor influencing the detectability of the villages, we have seen that according to that, the villages are detected when they are at lower altitudes, closer to valley bottoms, and closer to major pathways, and at a flatter slope, and of course further away from the forest. And how about the WorldPop dataset? If we had to compare it with the ground dataset, the Spearman correlation rank had give us a strong positive correlation. And by doing the linear regression between both datasets, we have seen that only 27% was explicated by, was shown by our models. That is to say that even though we have strong correlation, it is kind of difficult to locate those human settlements when they are compared to the ground data. And but what does it mean when you have to show it visually? As you can see, some area here in the northwestern part have more villages, but the global dataset do not detect them very well, and so we can see that densely populated area are well represented, whereas some areas like in those circles are badly represented. But that is our preliminary results, and what does imply in terms of policy design or conclusion. So first, remote sensing dataset help us to design a conservation policy in order to be more inclusive. That is to say that if we are not aware of the forest edge communities, it may have bad impacts for the conservation, but also it is a powerful tool to ensure that we implemented a fair and equitable conservation in estimating the local cost of conservation and by adopting adequate safeguard policies. But because as a result of a better data showing human settlement, we have a better understanding of the dynamism of the forest community's population and how important it is in order to engage the communities in conservation. And for our decision makers and policy designers in conservation, it helps us to have a more exhaustive list of project affected peoples and how we can use a better methodology in order to discuss and to have more study about the local cost of conservation, but also the social and economic impacts of conservation. Despite those global benefits of conservation, we are aware that some costs are borne by the poorest people, and remote sensing datasets and with a better detectability of human settlement will help us to achieve this goal of fair and equitable conservation. Thank you very much.